Okay, so this is the second question related to Thevenin's theorem that we will discuss. We have already discussed one question and a basic introduction to Thevenin's theorem in the previous video. So this is the second question, and here the objective is to find the Thevenin equivalent circuit across points A and B. Okay, across these 2 points we have a variable load resistance, so we have to determine the Thevenin equivalent circuit of this network across these 2 points. Okay, so let us do that. So again, let us redraw the circuit. B 1 ohm, 2 ampere, 12 ohm, 32 volt, 4 ohm. Okay, so you know that in Thevenin theorem two things are very important. First, the Thevenin voltage and the Thevenin resistance. So we'll find them step by step. So first step is to find the Thevenin voltage. Okay, first we'll determine the Thevenin voltage. So for that, as we did in the previous question, the 2 points across which we have to determine the Thevenin voltage, we have to open circuit it. So we have to remove the load resistor from here, and the voltage across these 2 terminals is the Thevenin voltage. So now we can use any circuit analysis technique. We can use mesh analysis or nodal analysis. So if we look closely, it will be very good to apply nodal analysis here. The calculations will be simple and fast. Okay, so here the voltage across these 2 points is VTH. As it is open circuited, no current flows through this, so 0 voltage drop. So here also the voltage is VTH, and as there is no resistor in between these 2 points, here also the voltage is VTH. Okay, so we will apply nodal analysis at this node. Okay, the same node it is. So we'll apply nodal analysis. So let us make it prominent. Okay, this is VTH at this point, and also at this point this is VTH. Okay, VTH and VTH. Let us assign the current directions. This, and this is towards. So let us apply the nodal analysis equation. This current, all the currents that are flowing towards the node, 32 minus VTH by 4. Higher voltage, higher node voltage, minus lower node voltage divided by the resistance involved, plus 2. These 2 currents are moving towards the node, that's why on one side, and this downward flowing current through 12 ohm, that is VTH minus 0, 0 means ground, by resistance involved is 12. Sorry. So now we have to determine VTH. That implies 32 by 4, 8 minus VTH by 4 plus 2 is equal to VTH by 12, or VTH by 12 plus VTH by 4, taking this to the right side, it is 10. That implies, taking the LCM as 12 VTH plus 3 VTH is equal to 10. That implies 4 VTH is equal to 120 plus VTH is equal to 120 by 4, which is equal to 30 volt. Okay, so VTH is equal to 30 volt. Okay, so we have got VTH is equal to 30 volt. Now let us write it here separately so that we know VTH is equal to 30 volt. Now we have to determine RTH. Okay, so let us do that. So now we'll do the second step, that is to determine RTH. So again, across these 2 points we have to determine RTH. So like we did in the previous question, to determine RTH across any 2 points, first we have to open circuit it, and then we have to find RTH across it. But also we have to do one extra procedure, that is deactivating the independent sources. Okay, independent sources are deactivated. Dependent sources are kept as it is, but here we have only independent sources, independent voltage and independent current source, so we have to deactivate them. So voltage sources are replaced by short circuit, current sources are replaced by open circuit. So 2 ampere current source will be open circuited and 32 volt voltage source will be short circuited. Open circuited. So here, if we want to calculate the Thevenin resistance across the points A and B, then we can easily see 4 and 12 ohm, they are in parallel and the equivalent resistance is in series with 1 ohm. So RTH is 4 parallel 12 plus 1, which is 4 into 12 by 4 plus 12 plus 1. This is 68 by 16, which is 4 plus 1. 48 by 16, that is 3 plus 1. Okay, 3 plus 1, which is equal to 4 ohm. Okay, 12 into 4 is 48. By mistake I said 68. Okay, 3 plus 1, which is equal to 4 ohm. So RTH is equal to 4 ohm. So we have got both VTH and RTH. VTH is 30 volt, RTH is 4 ohm. Okay. Now we will draw the Thevenin equivalent circuit. So the Thevenin equivalent circuit can be drawn as .30 volt VTH, and this is RTH equals to 4 ohm. This is the point A and B. Okay. So now if we reconnect this variable load resistance and give it any value and find the current flowing through it, let's say try to find the current flowing through it. Let's say the current, the variable load resistance value is equal to 6 ohm. In that case, the current flowing through it will be the Thevenin voltage 30 divided by 30 volt divided by 4 ohm plus 6 ohm, which is 10 ohm, which is 3 ampere. 30 volt by 10 ohm, which is 3 ampere. So likewise, if we change the values of RL, we can determine the current flowing through it or the voltage drop across it using the basic concepts of electrical circuit analysis. So here the point is, this circuit, the circuit network, this within the dotted lines, excluding the load resistance RL across the 2 points A and B, this network is same as 30 volt voltage in series with 4 ohm Thevenin resistance. The whole network, 32 volt, 4 ohm, 12 ohm, 2 ampere, 1 ohm, connected in the arrangement that is shown here, is same as 30 volt in series with RTH 4 ohm. We have replaced this whole complicated network with this simple arrangement, and that is the whole point of using Thevenin's theorem, to simplify a circuit. So here we found out the Thevenin equivalent circuit across point A and B as it was asked. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.